Hello and welcome to the first episode of SAF Pro webinar series. Today we will look at the application of Spectrum Compact for doing the radio link verifications from the ground level. So we will look at how to check whether the transmitter is on, what is the center frequency, and what is the channel bandwidth and polarization. So the Spectrum Compact family is one of the business lines for the SAF Tehnika, and it consists of handheld Spectrum Compact spectrum analyzers and signal generators. So Spectrum Compact is a tool which is designed for radio frequency verifications in the field, to do various link troubleshooting, signal coverage testings, radio parameter verifications. This is the application that we will be showing today in this webinar. So the Spectrum Compact is a really useful tool for doing the RF field verification tests, because it is designed to be as a truly handheld device, which is completely standalone, meaning it doesn't require any external devices to control it. It has instant-on functionality, and it has a built-in memory for data logging, and also the battery life is up to 4 hours, which is suitable enough for field operations during the day. Apart from the Spectrum Compact Spectrum Analyzer, we also provide a Spectrum Manager PC software, which we will be also using today for gather data and review, and to create spectrum reports for later use in the future. Also, what we will be using will be accessories, specifically the directional horn antennas, which are our critical component for doing the measurements from the ground level with Spectrum Compact. So if we look at the frequency range which is being covered by the Spectrum Compact Spectrum Analyzer, so this is the bar there in the top side of the picture. So with Spectrum Compact you can cover the frequency range from 10 MHz up to 87 GHz. As you can see, in total there are 7 different devices of Spectrum Compacts, which cover the frequency range from 10 MHz up to 87 GHz. And each of this device is a physical device dedicated for its own frequency range, meaning that you can select the device specifically for the frequency you will be doing the measurements in this specific day and for the specific application. So, as I've already mentioned, the handheld directional antenna is very important for this task. Here, because to capture the signals from the ground level, we need to have a gain of the horn antenna to get this the signal appear in the spectrum screen. In this particular example that we will be doing today, we will use specifically the antenna covering from frequency range from 10.7 gigs up to 17. The other accessories that we also include in the kits with the Spectrum Compact is the tripod, which is used for fixing the horn antennas, as well as we have multiple sets of waveguide to coaxial adapters, and also we have carrying cases to safely transport both the Spectrum Compacts and the horn antennas. So when we get to the accessories for the V-band and E-band Spectrum Compacts, so this is the Spectrum Compacts that are from 56 GHz to 87 GHz. There are also dedicated parabolic antenna with tripod, a horn antenna that is can attach directly to the Spectrum Compact. As well, there are waveguide attenuators if the signal that you are doing the measurements is too strong for the RF input on the Spectrum Compact. So you can add the attenuator. Before we go into details of how the measurements from the ground level work in case with Spectrum Compact and the horn antennas, a little glance on the antenna theory. So the antennas typically have this kind of typical radiation pattern where they have a single main lobe, which is into which direction the signal is being transmitted with the highest gain, and then there are side lobes. So those are the side lobes are actually for which we will be doing the measurements on those radio links from the ground level. So obviously we can't do the measurements on the main lobe, since that is focused to the other end of the microwave point-to-point link. So we will do it on the side lobes. From the side lobes, we can get the same information about the RF parameters of the radio transmitter, like what is the frequency of the transmitter, what is the bandwidth of the signal, and also what is the polarization of the signal being transmitted. So, and depending, of course, on the size of the antennas, the side lobes can be more evident or less evident according to the main lobe of the antenna. To have the best chance to successfully do the measurements, the RF parameter measurements from the ground level for the microwave point-to-point antenna, is that you would need to have the visual line of sight antenna to the antenna, and also you need to stand as far from the tower as high as the antenna is on the tower. So this is sort of the optimal location. So this means that at that point you have about 45-degree angle towards the antenna, and this is the angle where typically the antenna would have the most evident side lobe. This, of course, is very rough approximation. So whenever you're in the field, you need to look at various locations from which you have the best way to capture the signal, both from the perspective of environment around you and also to where you are standing towards to the tower. So, when we have the spectrum compact and the horn antenna oriented towards the transmitter for which we want to do the measurements, we turn on the device and set it to the frequency of our interest. So once we set it to the frequency of our interest, if the radio is transmitting, we will see that sort of the bump into the spectrum. This is like it's shown here in the picture. So this resembles that we have captured the signal, and from this then we can determine what is the center frequency of the channel, and also what is the bandwidth of the channel. So both of those things we can do with the help of the built-in feature called power in band. And this will also calculate the received signal levels. But in this case, we are more interested in verifying the channel bandwidth, if it is set to the correct value according to the license. Another RF parameter which we can verify using the spectrum compact and the horn antenna from the ground level is the polarization of the radio links. So since the radio links can both work in vertical and horizontal polarizations, it's sometimes necessary to verify which one exactly. So the way how to do it is that we use the horn antenna, which is in a single polarization. Depending on the orientation of the horn antenna, it can be in vertical or horizontal polarization. But what we are looking for is that whether the horn antenna is set in the same polarization as the radio links or is in different polarization. So in the images in this slide, you can see examples where the horn antenna and the radio link are in the same polarization. So this means that in that case, the signal levels will be higher. If the horn antenna and radio point-to-point link antenna is in different polarizations, then we will see that the total signal power will drop. So typically This difference can be anywhere between from 20 to 30 dB. So for some antennas, it can be less, but this is sort of the ballpark figure for which you would determine whether if they are transmitting a different polarization than you are using the horn antenna. Another very important feature for the Spectrum Compact is that you can save the measurement data into this built-in memory, and afterwards, after doing the field tests, you can return to the office and you can upload the saved data to the PC, with which you can later do the reports and gather this data for later use to compare it how the situation changes in the future, for example. So this is an example of how we can work with the measured data. So this is, in this example here, we are in Spectrum Manager PC software, we are determining what is the bandwidth of the signal, what is the center frequency, what are the signal marker values for the edges of the signal, and from that also we can create a report which can be saved as a PDF, or it can be created as an image, depending on what is the requirement from the organization. And now we will take a look at some practical demonstration how to do the measurements in the field with Spectrum Compact to verify the point-to-point radio link from the ground level. So before we switch to the field, I just want to go through some functions that we will be using during this demonstration, which can be also useful for doing the measurements in the field. We start with presetting the device. So this means that we are setting it to the default settings. So we clear out all the frequency, span, marker, etc. settings. So before we go into the field, so either you know the specific frequency for which you want to do the measurements, or if you don't, we can go to the marker menu. We can drag the marker to the specific point in frequency in the spectrum where we want to, for which we want to do the measurements. We can center to the marker. Then we can change the span. I can either input span manually, let's say 2000 megahertz, or I can change the span just by tapping on the right side to narrow span, or on the left side of the screen to widen the span. Another useful feature that you would definitely need in the field is the LNA, the low noise amplifier. This will improve the sensitivity of the receiver. So this allows to catch some relatively low-level signals, which is a very typical situation in the field. Also, what we will be using is the power in band. So this allows to visually measure what is the bandwidth of the signal that for which we are doing the measurements. So I will just give a quick demonstration. Right here, let's say I want to set it to 40, so we see that the blue area, it resembles the bandwidth of 40 megahertz. Then, also useful in the field, especially if it's a sunny day, I definitely recommend to use the high contrast mode. So this gives the switches screen to into the mode which allows it to better see it in the direct sunlight. We will also use the record function. So this means that we will record each and every sweep consecutively, and this allows to gather the data for later use. The other way how will gather the data is by using the save button. So this allows to save just a single sweep, and again this is useful for doing the reports. And we are here today near this communication tower to do the verification for the point-to-point microwave link from the ground level. We will be using today a set of Spectrum Compact and dedicated horn antenna to do the measurements from the ground level for this radio link. Okay, so we will start with our setup with unpacking and setting up tripod. We will start with setting up the horn antenna onto the tripod, then followed with the dedicated Spectrum Compact pocket. We will check the Spectrum Compact which we will be needing for today's measurement. If necessary, we have also a set of waveguide adapters if it's necessary to attach them to the antenna, because some antennas requires waveguide to SMA adapters to work. The others already have the coaxial port on them. And now I approximately position the antenna to be into the direction of those point-to-point radio links, approximately 150 meters up into the tower. So then now we can start the measurements. Okay, so when we have the measurement setup ready to perform the measurements, so we start by obviously turning on the device. And really important feature on the Spectrum Compact is that once you turn it on, in a matter of seconds, it's on and it's ready to do the measurements. This is very handy while we are in the field. So currently we are doing the full sweep from 6 GHz to 20 GHz, and we see two obvious signals appearing, but we know that the signal of our interest is around 14 GHz. So we will set the marker onto that spectrum, onto that signal. We will narrow down the span to 100 MHz. Now we see that we have a clear signal right here, so we can adjust. So the signal would be in the center. We can keep on narrowing the span down. So right now we are it's settled on the 3 MHz span. So now we have a clear signal. We see it, and right now, if we want to verify whether the signal is in the correct bandwidth, we go to the power in band settings, and we set the signal width to 1 MHz. So, and then we can orient it. And now, if we expect the signal to be a 1 MHz width, so obviously we can see that it is it is within the 1 MHz channel. So this blue area indicates how wide the 1 MHz is visually. So we can clearly see that the signal is in this correct in the correct bandwidth. And also we can from here we can also see what is the center of the center frequency of the signal, which is around 14 gigahertz and 33 megahertz. So if that is what we expect, so this means that it's everything is all right. Once as we done the channel bandwidth measurements and we measured what is the center frequency of the channel. So we can also check what is the polarization of the channel. So currently the antenna is vertically polarized. And to change the polarization, we need to either rotate the antenna or the waveguide on the antenna. What we will do here, we will rotate the antenna. So currently we have the signal power measurements of this channel is at minus 88 dBm. Now we do the rotation of the antenna, and we see that the power of the signal that we're measuring is now somewhere in area of minus 100, minus 80, 98 dBm. So we can see that the signal that we are measuring is in the vertical polarization. And as we turn it back to the vertical polarization, we see that the signal's level increase. Okay, if the setting and the application requires, it is also possible to have all this set up not only on the tripod, but you can actually place it onto the handle, where you can put it, hold it in all this setup in hand, and basically do the same measurements. So we attach handle to the base of the antenna. We have the spectrum compact as it was previously. Turn it on, start the sweep, and basically we can also see the signal. So this is more down to catching, finding the correct position where we can see the signal. If I would need to do a very quick check on the signal, this is how I could do it. But if I would like to do some longer measurements, or I don't want to hold it all the setup in my hands for too long, this is when I would use the tripod. And since we've done the measurements on the signals of our interest, we also want to save the data so we can later review it on the PC and do the reporting for our database. So we save the signal. We can do it one more time just to have multiple saves. And also what we can do is that we can record the signal level. Now we are recording each sweep consecutively. And we can also, just to make it more interesting, we can rotate again the antenna in different polarization. To do the comparative measurement, and now we can rotate it back. And we finished the recording. So now all this measurement data has also been saved on the internal memory on the Spectrum Compact, and so we can use it later for reporting. Okay, so we gathered the data that we needed for during those field measurements. So we checked the frequency, we checked the bandwidth, we checked the polarization of the signal. We also saved all this data so we can review it later in the office and also create reports in the Spectrum Manager PC software. So what we did, we uploaded the saved measurement data from the Spectrum Compact up to the PC, and now we will open it up through the Spectrum Manager PC software and do the post-measurement analysis. Okay, so now we have uploaded the gathered measurement data from the Spectrum Compact to the PC, and now we will open it with Spectrum Manager PC software. Just double click on the file of your interest, and it will show up on the screen. So what we have is a power and band value is being already calculated for this for the selected area of the signal bandwidth. What I will do, to make the signal better, I will change the display level here of amplitude. So now what we do, we have a signal for which we are measuring that power in the bandwidth of the signal is within the 1 megahertz bandwidth. What we can do, we can additionally add markers here on the screen. This then allows us to set edges, frequency edges of the signal. So this can be seen on the top right corner on the spectral graph. In this, you can add up to 10 markers in this menu right here. You can set the power in band of the signal. So this allows you just to visually represent what is the bandwidth of the signal that we did the measurements for. And also what we can do, we can create a report. So we go to the export menu and we select add to report. So it is now added to the report, so I can look at the report, what I have in there, and here you can see that we have this image of the spectrum that we had also on in the screen, and I can edit the report in the way how it is required for my organization. So I can adjust the logo. I can name the report. I can change which device that was used. So in this particular case, we did use the Spectrum Compact JA-AP52, and you can also add the latitude, longitude values, and it automatically shows here what is the signal, what is the level of the first marker. And then whenever you are ready with the report, you can print it into a PDF format, for example. In today's webinar, we looked at the application of using Spectrum Compact Spectrum Analyzer for doing the microwave point-to-point link verification from the ground level. We looked at and explained how to prepare the equipment for this task, how to position the horn antenna accordingly to the radio transmitter antenna. We discussed what are the optimal settings for the Spectrum Compact and how to verify the signal, how to check the signal's bandwidth and the center frequency and also the polarization. We also looked at how to save and record the signal and how it later can be used with Spectrum Manager PC software for post-processing and reporting. The majority of these tests are also available on our website in emulator section. Our Spectrum Compact emulator is a useful tool for RF engineers to train before going into the field. Thank you for joining today, and we hope to see you in the next episodes of SAF Pro webinars. Paldies!